high. In exercise EM-3 you will have to compare motors of different efficiency classes. Please note that cooling type and protection type should be the same for all the motors you are comparing. The topology for the system is the simplest, with just a motor and a frequency converter. Please note that the pump is going to be operated quite a lot of time at reduced load, just 25% of load. The pump parameters are given. So we'll have to find life cycle cost or cost of ownership for several alternatives, several scenarios with different energy price and different service life of the motor. So there are quite many variants to look at, as you may see, but these calculations will not have to be done in DriveConstructor, but on offline, on paper or in Excel, for example. So in the end you will have to define which motor suits best in each of the 4 scenarios with energy prices and service life, and as you may guess, the winner motor may be different in these 4 scenarios. I recommend you make a table in Excel as the one shown on the screen. So you see the cells shaded light blue contains the efficiency data, so you will have to make just 3 calculations in DriveConstructor for the 3 cases. The column C represents the case with the old motor with IE class 2, column D the new motor IE3, and column E IE4. So you will have to find efficiency for 100% load and efficiency for 25% load. You see in column G there are 2 times, so 0.3 corresponds to 30% of time and 0.7 to 70% of time. Well, you can also see in line number 5 there's number of hours in column B. That's 8,000, sorry, and then in line 6 there is a cost per kilowatt hour. This is according to the specification. Let's look into cell numbers C5. So there we find the expression for energy consumed by the pump with efficiency class IE2. So there you see the expression consists of 2 parts divided by plus sign, so the 2 parts are added up. The first part is for the operation at rated load, and the second part is for operation at 25% load. So you see the factor of 0.25 there. So the number 29 in front of each of the parts is load of the pump. So you may have a different number in your calculations there. This is just there for example. Now the same expression is highlighted with colors, so it's easier to see from which cells the parameters are taken. So you see, for example, that number of years of pump operation, number of hours per year, this 8,000 is there. Operational costs we can get by multiplying the energy consumed by the pump with cost per kilowatt hour. So you see that cell's number C5 is multiplied by cell number C6. So this is how we get OPEX. CAPEX in line 8 we just get from DriveConstructor. This is the cost of motor. You will find it in the report. And then finally in line number 9, total cost of ownership is made by summing up OPEX and CAPEX numbers. Then the same table can be copied in Excel, and you can create like a series of tables where you may have different years of operational lifetime, either 5 or 10 years according to the exercise description, and you can have the different cost of energy, 0.07 and 0.2. So by having the results in the 4 tables, you will have all the variants covered and you will be able to make your conclusions. So now we will play the video how to set up parameters and make the calculations in DriveConstructor. So these manipulations are quite straightforward, and I think it will not be needed to command them. So we will do it on mute. So thank you for watching. Bye bye.